folks, this is the solutions to the homework questions that were asked about the dot product. So in this first one, page 377 9b, we're going to use the rules about the dot product and what we're able to do. For instance, the distributive property of the dot product. And I'm going to go through this pretty step by step, so that I'm really taking care to show exactly what I'm doing. So the distributive property tells us that 3x dot x minus 3y, we can distribute that 3x using the dot product into that bracket. And then I'm going to do the same thing with this second bracket. It's kind of like FOIL, but we don't really call it FOIL. So here I'm distributing the x dot the negative 3x and the x dot the y, and then the negative 3y dot the negative 3x. It does work just like FOIL. But I'm just trying to show it in more steps so that we're really clear about what properties of the dot product we're using. So here we've got 3x dot x minus 9x dot y. So here I'm using that property of the scalar multiples that if we have any scalar multiples, it can come out front. And then I'm going to use that in this bracket as well. So that would be negative 3x dot x plus x dot y, and then plus 9 with the negative 3 and negative 3 here. I'm also going to use the commutative property that would be x dot y, and then negative 3y dot y. I'm going to go in a couple steps here. I see that these are like terms. So x dot y plus 9x dot y is 10x dot y. And then I'm going to distribute this negative sign, remembering that each of the dot products are just going to be scalars. So I can multiply each of those by the negative, like a negative 1 out front there. So here I'd have plus 3x dot x minus 10x dot y plus 3y dot y. So here I get 6x dot x minus 19x dot y plus 3y dot y. And I'm not sure, it may in the back of the book say that that's the magnitude of x squared and the magnitude of y squared. That's going to depend on your purposes, whether you convert the x dot x and y dot y into the magnitude form. Okay, we're going to determine k given two vectors and the angle between them. So this, we're looking at B. So we know that A dot B is going to be equal to the magnitude of A times the magnitude of B times cos theta. We're going to look at that two ways. So that's going to be 1 dot 0 k is the magnitude of A, so the square root of 1 squared plus 1 squared, times the magnitude of B, which is the square root of 0 squared plus k squared, put some brackets I guess, times cos of 45. So here when we do the dot product, I'm going to have 1 times 0 plus 1 times k equals, this is going to be the square root of 2 times the square root of k squared, and cos 45 is 1 over root 2. So when this simplifies, here I'm going to get k equals k, and then this root 2 and the 1 over root 2 are going to cancel. So this feels like it's unsolvable. Where does k equals k? But this is always true for every real number. And if we think about where those vectors are going to be, if I kind of think about that, and it is sort of lucky that this is in R2, so this is easier to see. And if I had vector A, which is 1, 1, there's vector A, and we want to have a vector 0k where theta is 45. And actually, I just noticed one thing that I did miss a little bit here. But I could have this vector be 0k, and I end up with a 45-degree angle, no matter how big that k is. So if k is anywhere along there. The one trick is that I missed, I went a little bit too quick here, is that this square root of k squared. And I'm actually going to add that back in. So where is k equal to the square root of k squared? And it's not true for all real numbers, but it is true for all positive numbers. And I'm actually going to take that greater than or equal to out because I can't have an angle with the if k was 0. I wouldn't have an angle because the 0 vector has no direction. So if we kind of imagine the square root of, let's say, 3 squared, that's the square root of 9, which is 3. The square root sign always means the positive square root. But if I had the square root of negative 3 squared, that would be also root 9, so 3. So this is not equal to the square root of that value squared. It's not equal to the original value if the original value was negative. And if k was like out this way, if k was a negative, then I wouldn't have a 45-degree angle. I'd have a 135-degree angle because that would be an obtuse angle between those two vectors, A and B. So k can be any real number greater than 0, and that will be true. That will form that 45-degree angle. Okay. So in R2, a square is formed by the vectors I and j. Sketch the square. Okay, so I'm going to go here, and I know I hat goes to the point 1, 0, and j hat goes in the y to the point 0, 1. So I think we can pretty clearly sketch out that square, that this would be the point 1, 1 and 0, 0. So we want to determine the vector components for the two diagonals. So I'm going to call that D1. And that's going from the origin to the point 1, 1. So that's going to be 1, 1. And then D2, that's going from the point 0, 1 to the point 1, 0. So remember with your subtraction, that's going to be 1 minus 0, so 1 in the x, and 0 minus 1, so negative 1 in the y. You could just as easily have drawn that going the other way from 1, 0 to 0, 1. You just get a negative sign, and it will still work out. So we want to verify that the angle between the diagonals is 90 degrees. So remember that whenever you see perpendicular, that I want you to think dot product is 0. So I want to basically prove that D1 dot D2 equals 0, and that will tell me that it's 90 degrees. So I'm going to do the diagonal 1, 1, dot 1, negative 1. So that's 1 times 1 plus 1 times negative 1, which is 0. So therefore, the diagonals are perpendicular. And then this one's kind of similar. We're kind of looking for missing vertex here. So here we have a rectangle, A, B, C, D, has vertices A, B, and D, and we want to determine the coordinates of vertex C. So we know that when we're labeling a rectangle or any shape, that the letters that you're given in that order, that's the way that they go around in order. So you have to be able to trace them, A, B, C, D. So you can't label this like a different way. You can't mix up, for instance, that C and D, because that would be the rectangle A, B, D, C. And the order really does matter there. That's going to be important. So things that I know here, I know, for instance, that vector AB is going to equal vector DC. And vector BC is going to equal vector AD. Things like that. So that these two vectors, just drawing that in, would equal each other. And these two vectors would equal each other. So this is not too hard to do to find vertex C if you know vertex D. But we don't. We're missing something important here. We're missing that middle term. So I could figure out, well, what's vector AB? And remember, subtract the end minus the start. So that's going to be 3. And 6 minus 2 is 4. And negative 9 minus 3 is negative 12. So I would know that vector DC would be equal to 3, 4, negative 12 as well. And that would help me just be able to find vector C, or vertex C, pardon me. But I don't know the Q value in D. So something important here that you may have missed is the fact that this is a rectangle. So we know that a rectangle, this is not just a parallelogram. We don't just know that these vectors are parallel. We know something important about the adjacent vectors. We know that these are perpendicular sides. Because it's a rectangle, we don't just know AB and DC are equal and BC and AD are equal. We also know that we have that 90-degree angle in there. So I'm going to say that AB is perpendicular to AD because I've got that 90-degree angle, and that then AB dot AD equals 0. So now I'm going to find vector AD. Remember the end minus the start. So 3 minus negative 1 is 4. Q minus 2, I don't know what that is. And 8 minus 3 is 5. So now I know that those two vectors dot producted with each other are going to equal 0. I can solve for Q. So here I've got 3, 4, negative 12 dot 4 Q minus 2, 5 equals 0. So 3 times 4 plus 4 times q minus 2 plus negative 12 times 5 equals 0. So 12 plus 4q minus 8 minus 60 equals 0. So 4q minus 56 equals 0. And then we get q equals 14. So now that we have that q, now we can use these equal vectors to find c. So I'm going to say, let's see, I'll just say that it's x, y, and z. So if D now is 3, 14, and 8. So now I know that AB equals DC, and I know that DC is going to be the end minus the start. So 3 minus x, should have given more space there. So DC is 3 minus x, 14 minus y, and 8 minus z, and that will equal the 3 for negative 12. So 3 minus x equals 3, 14 minus y equals 4, and 8 minus z equals negative 12. So here, x is 0, y is 10, and z is 20. So point C is 0, 10, 20. So we found point D, found the Q value there, and then use the equal vectors to find C. And the next one is from the mid-chapter review, so I'll do that in a separate video.